Welcome to OwlsPrep. This is CIE 9709, A-Level Maths, Paper 1, Topic 1.4, Circular Measure. Why is a full turn 360 degrees? It's an arbitrary choice. Swap it for the radian, an angle measured by the arc it sweeps, and a circle's arc length and sector area each fall out of a single clean formula. Let's dive in. So what is a radian? Take a circle of radius r. If you walk along the edge and arc length exactly equal to r, 1 radius, then the angle you've swept out at the center is defined to be 1 radian. That's the whole definition. 1 radian is the angle whose arc equals the radius. Now go all the way around. The full circumference is 2 pi r, which is 2 pi radii laid end to end, so a full turn is 2 pi radians. A full turn is also 360 degrees. So 2 pi radians equals 360 degrees, and therefore pi radians equals 180 degrees. 1 radian works out to about 57.3 degrees. Radians are just a natural way to measure an angle, using the circle's own radius as the ruler. Because pi radians equals 180 degrees, converting is easy. To go from degrees to radians, multiply by pi over 180. To go the other way, from radians to degrees, multiply by 180 over pi. A handful of angles come up again and again, and they're worth knowing by heart. 30 degrees is pi over 6, 45 is pi over 4, 60 is pi over 3, 90 is pi over 2, and a straight line, 180 degrees, is pi. From A-level onwards, angles in pure maths are almost always given in radians, so get comfortable thinking in them. Here's the payoff. When the angle is in radians, arc length has a beautifully simple formula. A whole circle, angle 2 pi, has arc length 2 pi r, the circumference. A sector taking up some fraction of that turn has an arc in the same proportion, and the algebra collapses to just s equals r theta. Arc length is the radius times the angle in radians. For example, radius 5 centimeters and angle 0.8 radians gives an arc of 5 times 0.8. That's 4 centimeters. Notice the angle has to be in radians for this to work, which is exactly why we bothered defining them. Sector area works the very same way. A whole circle has area pi r squared. A sector is that same fraction of the whole, and it simplifies to area equals a half r squared theta, again with theta in radians. With radius 5 and angle 0.8, the area is a half times 25 times 0.8, which is 10 square centimeters. One more shape you'll be asked about, a segment. A segment is the region between a chord and its arc. You get it by taking the sector and cutting off the triangle formed by the 2 radii. So the segment area is a half r squared times theta minus sine theta. Sector minus triangle. That's the trick for every segment problem. For instance, with radius 6 and angle 1.2, the segment is a half times 36 times 1.2 minus sine 1.2, which is about 4.8. And a crucial warning. When you compute sine 1.2, your calculator must also be in radian mode. Using radians for the angle, but forgetting to switch the calculator for the sine is the most common way to lose the marks. And one last thing. The perimeter of a sector is the 2 radii plus the arc. That's 2r plus r theta. It's a common ask too, so don't only do the area. So that's topic 1.4, circular measure. First, a radian is the angle whose arc equals the radius, which makes pi radians equal to 180 degrees. Convert with pi over 180 and 180 over pi. Second, once the angle is in radians, arc length is s equals r theta, and sector area is a half r squared theta. And a segment is just the sector minus the triangle, a half r squared, times theta minus sine theta. The one rule that saves you marks. Always put the angle in radians before using these formulae. Next up is topic 1.5, trigonometry. See you at OwlsPrep.com.